Alright, the last part of our first section here is going to give us a shortcut on finding the maximum or the minimum and helping us find the vertex a little bit quicker than having to go all the way through completing the square. So let's do a little setup here first. So we're going to start with f of x equals ax squared plus bx plus c. Now, since we've gotten so good at doing completing the square, let's do some completing the square with this as well. So our constant is c, so we're going to bring the c over to the left side. Leaves us with ax squared plus bx. And then that lead coefficient of a, remember, we have to simplify by factoring that out, which is going to leave us with x squared plus b over a times x. So all I'm doing is dividing this by a to get me x squared, divide this by a to get me b over a times x. Then of course we have to do our plus something squared step. So on this side we're going to have f of x minus c plus a times something squared. Now again, remember that something is half of this. So that's going to give us actually 1/2 times this is b over 2a. So on the left side here, a little bit uglier than what we had before, but this is going to turn into b squared over 4a squared. And then when I multiply that by a, the a and the a squared are going to reduce. So we're actually going to take that down one step, and we're going to end up with b squared over 4a. And then we've got minus c plus that in f of x. So you can do the math there if you want to expand that out further. On this side, shorten it up, our two squares become one step. So x was one thing that was squared, and b over 2a was the other thing that was squared. So the two squares become one. And now this entire part right here is actually going to be our constant, so we can bring that over. So we're going to get f of x, oops, and that's pretty sloppy, equals a times x plus b over 2a, all squared. And then when we brought these over, it turned into plus c minus b squared over 4a. Now the main part of this is, this part right here is our h. So when we take that value for our h, our vertex actually gives us this. Our h value, or the x value in our vertex, is now negative b over 2a. And then of course, anytime I take my x value, I can plug it back in up here to find a y. So I'm going to plug x in this case my x is negative b over 2a. And there's my vertex. So let's put this to use and show you how it can make things a lot quicker depending on what kind of situation we have here. So in this one, this is what we're going to start with. We're going to start with f of x equals 2x squared minus x plus 1. Alright, so again our coefficients are a is 2, b is negative 1, c is 1. So if I'm going to figure out what my x value is for my vertex, I'm just going to do the opposite of b all over 2 times a. So the opposite of negative 1 is 1, 2 times 2 is 4. So there's my x value. Now f of x, or my y value, pretty simple. I just take 1/4, plug it in up here. So 2 times 1/4, all squared, minus 1/4, plus 1. So let's simplify this. So I'm going to get 2 times 1/16 minus, and I can put these two together by turning this into 4/4. So I'm going to get negative 1/4 plus 4/4 is going to be plus 3/4. And this will reduce into 1/8. So now I've got 1/8, and let's do a common denominator again and turn that into 6/8. And I can add 1/8 plus 6/8 and get 7/8. So my vertex for this particular problem, the x is going to be 1/4. The y value is going to be 7/8. Now I know a couple things on here. I know I mentioned max and min. Well, there's my a value. It's positive. So I know that this is going to open this direction. So I know on this, my line of symmetry, or my axis of symmetry, x equals 1/4 is my axis of symmetry. And I know the 7/8, because it opens up, it has a definite bottom. 7/8 is my minimum. So I can go fairly quickly, even with some nastier numbers dealing here with the fraction, and find a vertex and plot it and know some of my general idea of what my shape is going to look like. So, a little quicker way of finding your vertex.